Reverse phase chromatography is a technique using alkyl chains covalently bonded to the stationary phase particles in order to create a hydrophobic stationary phase, which has a stronger affinity for hydrophobic or less polar compound. So by using HPLC, we can actually find out that if there is really 11 mg of caffeine per 100 gram, as mentioned in the packaging.
For sample preparation, take 0.5 ml of tea into volumetric flask and dilute it with mobile phase until 50 ml. And then prepare the standard using zero dilution. The concentration of the standard solutions are 0.5 ppm, 1 ppm, 2 ppm, 4 ppm, and 8 ppm. And then 0.25 ml of caffeine stock solution is required to prepare 0.5 ppm of standard. And add the mobile phase up to 50 ml of the volumetric flask. Filter the solution to get rid of impurities.
Hi there, this is the HPLC machine, and these are the different components that make up the HPLC machine. As you can see here are the pumps, and then the column goes in here and it's in an oven. Yeah, I can't open it right now, but hi, okay, so we are going to open this now to access the tray. This is the trays, and we don't have to pull it out so soon. Like here, there are numbers on the tray, so we're going to insert these like valves into the appropriate trays corresponding to the number that they are supposed to go into. Okay, here 0.5 goes into 1 goes into 2 goes into 3, 4 goes into 4, 8 goes into 6, into 5, sorry, and sample goes into 6, yeah, that's the end, and then we just close it. Okay, so what we're doing here is that we are running the software. We're just entering the data and the name of the samples together with the corresponding positions on the tray, and then we run the batch, and after the HPLC we are entering the data into a Word document.
So this table shows the retention time and peak area of the standard Andel sample. This graph shows the peak area against concentration of diluted standard caffeine solution, which is directly proportional. This is the chromatogram of the sample, which shows the peak area and the area under the curve. By using the standard curve equation and the absorbance unit, which is the area under the curve, we can actually calculate how much of caffeine is contained in 100 grams of the tea. The reason the concentration of caffeine in the black tea in this experiment is higher compared to the one listed on packaging is that the steeping time for the tea was different when tested by the manufacturer that was conducted in the experiment. Retention time is actually the amount of the time between the injection of a sample and its elution from the column. Based on the standard solution chromatogram, retention time shows can help to identify the caffeine peak area in the tea sample chromatogram. So the calibration curve is a general method for determining the concentration of a substance in an unknown sample by comparing the unknown to set of the standard samples of known concentration. It is important to conduct this calibration curve in order to understand the relationship between area under the curve as well as caffeine concentration. The equation of the standard curve are used to calculate the concentration of caffeine in our tea sample. In this experiment, diode array HPLC detector is used. It is the most commonly used to record the UV visible absorption spectra of samples that are passing through a high pressure liquid chromatography. The advantage of diode array HPLC detector is the ability to select the best wavelength for analysis, and it can measure multiple wavelengths at the same time. In the conclusion, the concentration of caffeine in black tea samples found in the experiment is 40.82 mg per 100 gram, which is not 11 mg per 100 gram as stated at the hypothesis.